Welcome back to Cloud 42, I'm James. Today we are going to continue work on the Toolpost grinder. This is going to be part 11. The only thing we lack at this point for having a spindle mounted on the lathe is the actual Toolpost clamp itself. So that's what we're going to get started on today. If you haven't taken a moment yet to subscribe to the channel, I would encourage you to do so, and thank you very much to those of you who have subscribed and those of you who have left comments. I find that very encouraging, and that encouragement is really the reason I keep making these videos. So, if that's something you are interested in, go ahead and click the subscribe button and you'll get notified when each new video comes out. Let's go over to the bench and take a look at the plans. Okay, these are the drawings for the Toolpost block. You can see it is a block. We're going to make it out of steel. It's got a dovetail in one side. It's shown here with some pins, but this is a dovetail that's going to be used to mount it to an AXA size tool post. There's a bore through it to accept the spindle. It's slit, and then there's a couple of clamping screws to clamp it closed. And then there's a couple of other features. There's a height adjuster that's part of the AXA tool post system. This is the block of stock that we're going to use. This is cold rolled steel that I've already squared up and gotten to size. Now, I did this in the mill using a 2.5 inch carbide face mill. It's just a 4-flute TPG inserted mill. Now this, as it turns out, in steel is a lot of mill for my little grizzly mill. I was running 20 thousandths depth of cut, 20 inches a minute at 2200 RPM, which is a really fast surface speed, like 1400. But that's what it took to get this kind of smooth surface finish on the material. The chips were coming up to dark blue, almost black. I was pushing it way too hard. And the mill was complaining and just barely taking that cut. But what I was finding is that if I went any slower, I just didn't get this nice, smooth, glossy surface finish. So, I probably pushed it a little bit too hard. I did chip one insert in the process and had to replace them. But, it is kind of hard to argue with that surface finish. So it took way longer than it should have. Again, the mill is just, it's a low-powered benchtop mill. It's not a Bridgeport. It's not a horizontal mill, so removing a lot of steel is not its forte. Still, that was almost a cubic inch per minute in steel material removal rate, and that's pretty impressive. So I'm pretty happy with that, how that turned out. But that's not the focus. The focus today is going to be to look at this dovetail. Now let's talk about the dovetail geometry here for a minute. Now, the dovetail itself, the depth is easy to measure. There's actually a small relief here in the middle so that the dovetail bears on these surfaces. I have something to point with. So the dovetail bears on these surfaces right here, and then this section in the middle is actually relieved down 5 thousandths of an inch so that the dovetail of the tool post grinder isn't bearing across that entire surface. It's just bearing on the ends. So the critical dimension in order to make this fit and to make the tool post clamp on it with the same stroke of the handle as with other tool holders is really the width of this dovetail. And the way you measure the width of the dovetail is with pins. So this is a 2-to-1 scale drawing of this. So you can see the dovetail shape here. You can see the little relief, 5 thousandths in the middle, and then you can see the pins. Now normally, for this size of dovetail, you grab a couple of 1/4 inch pins and you drop them in there, you'd measure the distance between them. I don't have a couple of 1/4 inch pins, I have a gauge pin set. So I've got a 1/4 inch pin, 250 thousandths, and I have a 249 thousandths pin. So I did the math and drew this up in Fusion 360 and figured out what the correct dimensions were, working from measurements of another tool post holder, another tool holder that I have. So I've got my 250 and 249 pins, and I can drop those in here. And then I've got to measure accurately the space between them. So how do we do that? Do that with gauge blocks. So there's a 1-inch gauge block, and that rattles. So let's take a 90, and a 90 and a 100 would fit that. Let's try 90 and 900 and 110. So this would be an inch plus 10 thousandths. And that doesn't fit. Try it with a 105. So that's an inch 5 thousandths, still play. An inch 7. There's still just a little bit of play in that I can feel. Here's 1 inch 8 thousandths. And it just drops in. It moves freely. There's no play at all. Let's try 1 inch 9. Yeah, that's not going in. So 1 inch, so 900 thousandths plus a 108 block. So 1 inch 8 thousandths is the space between those two pins in this tool holder. And as you can see, I've got on the diagram, I've got 1 inch 7.5 thousandths. So I must have measured a different tool holder that had a slightly different tolerance. So this is how we're going to measure the completed dovetail as we're cutting it to make sure that we're hitting the correct size. Talk about the cutting operations here. I'm going to do this in several steps. The first thing is just going to be to remove the bulk of the material from the opening here. No sense getting a dovetail cutter involved. They're delicate, they're slow, they tend to chatter, and there's no sense getting that involved until we've got most of the material out of the way. So I'm going to use this. This is a 3/8 inch fine pitch rougher. This happens to be a YG1 tank power fine pitch rougher. These are fantastic. I love them in this little mill. And we'll just come in and do an adaptive clearing step and remove most of the material. Then before we can continue, before we actually cut the dovetail, because I'm using a small 60-degree dovetail cutter, the height of the edges here is not the full depth of this slot. So this is not big enough to take it in one pass. So I've got to cut these facets on top first. And I'm going to do that just by putting it in at 45 degrees in the mill vise, and then I'll come back with a 1/4 inch tool like this and come in and cut those corners off here and here. And cut those off, cut those facets. Then come back with the dovetail cutter, and after doing a little bit of cleanup on the bottom, we'll use the 1/4 inch carbide end mill to just clean up the bottom and get that all to the correct dimension. And then we'll come back with the dovetail cutter and actually cut the sides in 2 or 3 steps until we have that cleaned out to the correct size. So I think that's all we need to look at here. Let's go over to the mill and get started. Okay, let's get the stock set up in the mill and rough out the dovetail. Okay, we don't need any parallels because the piece is nice and tall. Get a good grip on it, and then tap it down just to make sure it's bottomed and level. There we go. Okay, first tool is an edge finder. Just need to locate the part. Yeah, I need to turn on the air compressor. Okay, now we just need to zero up on the center, and we'll just do that by finding all 4 sides and using the half function on the DRO. Okay, sanity check just to make sure we've got that right. G0, X0, Y0. Should put us right in the center. And that looks entirely plausible. Now, I'm not going to try to set the Z height using the edge finder like I usually do. And the reason is because I don't want to run the roughing end mill in a collet holder. I want to run it right in the collet of the mill to minimize the stick out and maximize the stiffness. These are going to be some heavy roughing cuts, and I just really want the maximum stiffness I can get. So I'm going to take the Tormach collet out of here and put in an ordinary 3/8 inch collet. And I'm going to put the end mill in and choke it up as much as I really can. And we'll torque that down directly in the spindle. Now, since I do have a tool table set up in Mach 3, I do have to have the correct tool set when I make this cut, or when I set the Z height, and that is 105. So I will set 105. And then I will do the same thing I usually do and set the height with a 10 thou shim. Okay, there, it's just gripped it, so I'm going to set that as 10 thou. So I am set to tool 105. Code says it's going to use tool 105, and it says my Z height is 10 thousandths, so I should be good. Okay, so now the first cut is just an adaptive clearing. We're going to take it in 2 levels. Take about 93 thousandths, because that's a quarter of the end mill diameter per pass, and we're just going to work our way through here, and we're going to do it 200 thousandths deep at a time and finish out the full depth of the dovetail in 2 passes. Now, in theory, this tool should be able to take that full depth, because it's only 1 diameter. It should be able to take that full depth in 1 pass, but due to the stiffness of the mill, I'm going to take it a little bit easier than that. Just because the tool can handle it doesn't mean the mill can handle it. Okay, we're going to run this around 1900 RPM. And we're going to run mist coolant. That's a lot. Let's back that off a little bit. Okay, here we go. Okay, that looks beautiful. I don't have a step on either side, which means I didn't lose anything. This is always the thing that worries me on a CNC conversion light mill like this, is that ultimately I'm going to lose steps. But that looks beautiful. I'm very happy with the performance of this end mill. Let me get this cleaned up, and then we'll work on cutting the facets. I got some of the chips wiped away here and got this cleaned up a little bit. I'm not going to bother deburring anything because the burrs aren't going to be in the way of getting this clamped correctly, so that's not going to be a problem. We'll deburr when the rest of the cutting's done. Okay, now we just set this up at a 45-degree angle to cut the facets. And really the only part of this that's really critical is the angle. I don't have to worry too much about any of the rest of the setup because the vise will pull everything else into position. So I've got a 45-degree angle block here. Close the vise jaw on it. Now I'm going to release and tighten everything up here again and then clamp a couple more times just to make sure. I think I got a chip or something under this. Well, that is odd. Oh, there's a chip. There it is. If it doesn't feel right, check it. Because if it doesn't feel right, it probably isn't right. There we go. That's much better. Now, this edge is going to be sitting down on the bottom of the vise, and it has been deburred with a tiny, tiny chamfer with a file that's not even. But again, that doesn't matter, because as long as we're square up on the 45-degree block, the vise is going to square up everything else that we care about. Okay, that appears to be tight. Okay, I'm happy with that. Now we need to zero on the top center of this edge. We've already zeroed the Y front to back because this is the same part, same dimension. We don't have to worry about that, though I probably will check it. To zero on this side to side, we'll use the little split cylinder edge finder we made in a previous video. And let me grab the edge finder. Okay, now let's just do the same thing. Let me just go ahead and do the Y first just to verify that we're good. There it is, we just gripped it. And so the Z height here would be 0.375 plus the height of the shim, so it would be 0.385. Let's see, how do these look in terms of evenness? It's hard to tell because the light's on them differently. I think just judging from the measurements I can take, the reason one of these looks just slightly wider than the other to me is because of the differing texture and the differing tool pressures on the roughing passes, and those will be taken out shortly when we come back and finish it. Okay, the first tool is going to be tool 8, which is this 1/4 inch carbide end mill again. And we're going to do a few things with this. We're going to surface the floor of this. We're going to form that center recess plus the step on the side. And we're also going to take a couple contours on the sides and get those smooth out to width before we start cutting the dovetail. Remember what I was doing there? Torque this down. Then we'll go back up to 1800 RPM. Okay, now looking at these two facets, they're not too bad. Okay, so that we've established the contours of the bottom, and now we need to get the dovetail in here. Dovetail cutter and actually cut the dovetail. Now we're going to run this dovetail cutter nice and slow. Check the setup sheet, but I think we're going to go about 300 RPM. And we're going to take 1 thou per tooth, which seems like kind of the minimum we really want to take. And it looks like we jammed it up. Okay, so that's too much. I think what I'm going to do at this point is I'm going to cut the dovetails by hand. I don't think there's any point in trying to get in here and figure out the right feeds and speeds. So that's easy enough to do. Let me reset the mill and get everything zeroed again, and I'll be back. Okay, I got this all set up again. Check the tram on the mill, everything's good. And what I'm going to do is I'm going to come back here and repeat these dovetail cuts. I'm just going to do them by hand. And I've got the coordinates here off of the machine. I was taking 50 thou at a time, which is apparently way too much. So I've got already set my Z, and I know I need to go X plus or minus 0.438 on the X. And so now I'm just going to kind of find it and take little bites until it's done. Going to get up here to where it hasn't been cut yet, and then I'm going to move in until I make contact. Okay. Now let's just take 10 thou and see how that works. Okay, that gets me to my initial number, 438. I thought maybe that cutter was getting dull, but it still feels fine. The way it was behaving. Oh yeah, and the dovetails are nice and smooth. Well, let's just take a measurement here and see where we are. Here are our 2 pins. Okay, 1-inch block won't quite go in, so 950. Yeah, 950 fits easily. So we'll do an 850 plus a 120, which would be 970. That fits. 850 and 130. No. 850 and 125. Very close. 850 and 123. Yes, that's it. 850 plus 123. So we're looking at 973. It means we're looking at 455.5 in each direction. Okay, let's make those cuts. We were looking for 1.0075 technically. So 1.008 going in tight, I think, is going to be fine. Very good. I think we nailed it. Okay, let me take this out, get it deburred, and go see how it fits in the lathe. Well, that is the Dovetail complete and 2 size. I did a little bit of test fitting after I turned off the camera, and it fit on here fine, and it would have worked, but it was just a little bit tight. It was kind of a machinist fit rather than a good, sliding tool fit that would be easy to use on a day-to-day basis. So I went back with the Dovetail in the mill, and I actually took another 1/2 thousandth off of each side. Now, I think that the reason why it was a little bit too tight is with the pins, we're of course measuring the position of the sidewall in relation to the bottom of the Dovetail groove. But of course, the way the tool post actually works is it registers on these faces. So it registers on the top and on the inside. And so it's a little bit different registration, and if the depth isn't exactly the same, then the fit isn't going to be exactly the same. And I measured that a long time ago when I did the drawings. I didn't think to measure that again today. So it was just a little bit too tight. Anyway, I came back and took another half a thou off of each side, and now it fits great. Just drops on here, moves very easily, and it's easy to lock down. It also fits on the front, which is where we'll probably be using it most of the time, and it locks securely. So of course, to finish this out, we're going to need to punch an 1.5 inch hole through this, slit it, put in some threaded holes for clamping screws, and a hole in the top for a jack screw for the height adjuster. And we'll continue working on that next time. In the meantime, if you're enjoying these videos, please give me a thumbs up, leave me a comment, click subscribe so you'll be notified of future videos. Thank you for watching.